Assalamualaikum. I am Rafiq Mustafa, a fifth year student of Russian Medical College. Today we'll discuss on bleeding time, prothrombin time, and activated partial thromboplastin time, or known as APTT. In our medical life, we normally memorize these things like the disease where bleeding time is prolonged, or prothrombin time is prolonged, or APTT is prolonged. But but if we understand this topic well, then I think this that we don't need to memorize these things. So let us make it easy. Before discussing those topics, first we need to know some physiology. The first one is platelet structure. There are many receptors on platelet, but in the context of discussing the bleeding time, prothrombin time, and activated partial thromboplastin time, we need two receptors to be well known of. The first one is GP1B, and the second one is GP2B3A. So let's start. Here we see the GP1B receptor. The function of GP1B receptor is to attach with von Willebrand factor, and by attaching with the von Willebrand factor, it starts adhesion. The second receptor we need is the GP2B3A. The function of GP2B3A receptor is to aggregate with one platelet to with another platelet, and by this way, by the fibrinogen, they get attached with each other. Okay, the next. The next thing is what are the substances released from platelet. In the platelet, there are many substances which are released from them. Some are from the membrane and some are from the cytoplasm. From the membrane, the substance which is released is thromboxane A2. The function of thromboxane A2 is to call other platelets at the place of injury, and from the cytoplasm, the substance released are ADP, serotonin, and calcium. Among those three, I need to know more about ADP. This ADP helps to this ADP helps to express a GP2B3A receptor on its surface. So go further. Now the structure of blood vessel. Here we know from the first year there are three layers of blood vessels. One is tunica adventitia. This one is tunica. This one is tunica adventitia. This is tunica media, and this last part is called tunica intima. In the tunica intima, there are two parts, mainly the endothelium, which is marked here, and below the endothelium is the subendothelium. Here, during an injury of that vessel, the endothelium get damaged, and due to the damage of the endothelium, the subendothelium get exposed, and from there, the next step started, which is called the primary hemostasis. So, we start the next stage, primary hemostasis. So here we see that this is the endothelium and there is a damage. 1 minute, please. There is endothelium and there is a damage. And due to this damage, there is in the subendothelium, there is a substance called von Willebrand factor. Here is the von Willebrand factor. When the endothelium is damaged, the subendothelium get exposed. The von Willebrand factor will also exposed. And due to this exposure, in the first picture, we have seen that there is a receptor called GP1B, and this is a GP1B receptor. This GP1B receptor bind with the von Willebrand factor and start the first attachment of the platelet. After attaching the platelet does something more. First one is it releases thromboxane A2, and we have told that thromboxane A2 cause other platelets to the site of injury. We see that the platelets are coming to this site. The next thing is that after releasing of thromboxane A2, it also releases ADP. Due to the releasing of ADP, the GP2B3A receptor, here it is the GP2B3A receptor, GP2B3A receptor, they get exposed to the surface. And after this exposure, fibrinogen comes and fibrinogen comes and the two platelets attached by fibrinogen via the GP2B receptor, GP2B3A receptor. After that, a structure is called primary hemostatic plaque. This whole structure is called primary hemostatic plaque. But this is a very friable structure. It can be dislodged very easily. So to make it more strong, uh, then the coagulation pathway will start and there will be a fibrin cover. Let's see how it forms. This is called the secondary hemostasis or the coagulation pathway. Here, there are two pathways. One is the extrinsic pathway, another is the intrinsic pathway. First, we start with the extrinsic pathway. If there is any burn or tissue trauma, then a substance is released called tissue factor. The tissue factor causes activation of the factor 7. It causes the activation of the factor 7. Then factor 7 turns to factor 7A, which is called activated factor 7A, activated factor 7. This factor 7A then activates factor 10, and then the factor 10 again activates, and it forms factor 10A. By this way, factor V, it activates factor 5, factor 5A, then factor 2A, and factor 1, which is called fibrinogen, and the factor 2 is called prothrombin. And then the activated factor 2A is called thrombin. Now we go the intrinsic pathway, which is more common. Both are common, but the intrinsic pathway is very much interesting. At first, the factor 12 is activated, and intrinsic pathway is normally due to injury to the endothelium. After that, factor 12 is activated, then factor 11, then factor 9, then factor 10. By this way, factor 5, factor 7, factor 1. Now, the thing is that in our medical life, we read some diseases like hemophilia. In hemophilia, we all know there is deficiency of factor 8 and factor 9. So in this pathway, we see that factor 8 and 9 both are in intrinsic pathway. And the main thing is that if any pathways involve, any coagulation factors involved in the intrinsic pathway, then the APTT will prolong. What I say, if the intrinsic pathway is active, if there is any problem in intrinsic pathway, then the APTT will be prolonged. And if there is a problem in extrinsic pathway, that means only the factor 7 is affected, then the prothrombin time will be prolonged. So by this way, we can see that in hemophilia, there are factor 8 and factor 9 deficiency. So what time will be prolonged? This will APTT will be prolonged. This is so much easy now. The next thing is that vitamin K deficiency. We know that vitamin K deficiency is the K dependent coagulation factor is factor 2, 7, 9, 10. Here we see that factor 2 is in common pathway, factor 7 is in extrinsic pathway, factor 8 and factor 2, 7, 9, 10. 9 and 10, 9 is present in factor 2 intrinsic pathway, and factor 10 is present in common pathway. If the common pathway is involved, then both PT and APTT gets prolonged. So what I have said, if the common pathway is involved, then both prothrombin time and APTT will get prolonged. And if the factor 7 is involved, then there will be prothrombin time will be prolonged. And if the intrinsic pathway is involved, then that means factor 9 is involved, then APTT will be prolonged. So in vitamin K deficiency, there will be both prothrombin time prolonged and APTT prolonged. Now the next, we go, sorry. So now we want to go back with with the previous slide. Here in this figure, we see this, the platelets gets attached with the GP1B receptor will have one Wunderman factor, and by the GP2B3 receptor, it attaches with another platelet. We know there's a disease called ITP, idiopathic thrombocytopenic purpura. In this ITP, there will this ITP, there is deficiency of GP. There's an antibody formed against the GP2B3 receptor. So the peptide will not adhere with each other. So the peptide will not be attached. So then at that time, the bleeding time will be prolonged. Now another common disease, which is called von Willebrand factor, von Willebrand disease. In von Willebrand disease, there will be von Willebrand factor deficiency. So here we can see that what is the function of von Willebrand factor? It attached with the GP1B receptor. It attached with the peptide by the GP1B receptor. So peptide will not get attached. So which time will be in prolonged. So it will be bleeding time will be prolonged. So in von Willebrand deficiency, there will be bleeding time will be prolonged. But another interesting thing that we don't know, that another function of von Willebrand factor is to protect the factor 8. So in the coagulation pathway, in which pathway, intrinsic or extrinsic, the factor 8 is involved. The factor 8 is present in the intrinsic pathway. So in von Willebrand disease, both platelet can get attached and the factor 8 will be consumed. So APTT and bleeding time both will be prolonged. So in a nutshell, if we see that in ITP, the bleeding time is only prolonged. In hemophilia, only the APTT is prolonged. And in the von Willebrand disease, bleeding time and APTT both are prolonged. And vitamin K deficiency, we call factor 2, 7, 9, 10, both are mean time and APTT is prolonged. So I speak it again. In ITP, the problem is that the peptide will not get adhered to each other, so bleeding time will be prolonged. In hemophilia, sorry, there's a mistake. Sorry, it's correct. In hemophilia, only the factor 8 and 9 will be deficiency. So it will be present in intrinsic pathway. So APTT will get prolonged. Now the von Willebrand disease. In von Willebrand disease, we see that peptide will not get attached with the von Willebrand factor, and factor 8 will be consumed. So BT and APTT both are prolonged. And vitamin K deficiency factor, coagulation factor 2, 7, 9, 10. So it involves both common pathway, intrinsic pathway, and extrinsic pathway. So PT and APT is prolonged. Thank you. If you like this video, please like and subscribe.